Roush. I'm the acting director at the Knight Science Journalism program at MIT. I'm also a 1994 PhD graduate of MIT's program in Science, Technology, and Society, so I'm both an alum and your moderator and host today. And I'm about to introduce our panel today, who will be talking to us about their experiences as faculty at various universities around the country. But first, just a note on logistics. So we're going to be structuring this 45-minute session around your questions, for the most part. To ask a question, take a look at the form below the screen and type your questions in there. We have a producer behind the scenes who will be watching for your questions and feeding those to me, and we'll get to as many of those questions as we can as the session goes on. So let me start by introducing our panel. Our first panelist today is Tracy Hammond, who is the director of the Sketch Recognition Lab and an associate professor of computer science and engineering at Texas A&M. Tracy is the recipient of a 2000 PhD from MIT, and I'll let her talk about her PhD research and what department she was in here when we get to her. Next we have Downey, who is a 1989 MIT undergraduate alum who earned his master's degree here as well before pursuing a PhD at Berkeley, which we will overlook. Alan is a professor of computer science at Olin College of Engineering here in the Boston area. Lastly, we have Ari Trachtenberg, who is a professor of electrical and computer engineering at Boston University. And Ari earned his bachelor's at MIT before pursuing graduate work at Illinois. So welcome to our panelists, and we'd like to start off by having each of you tell us a little bit about your current research and kind of expand on my very sketchy introduction. So why don't we start with Tracy, with you at Texas A&M. Take it away.
Hello, welcome everybody. I'm Tracy Hammond. I'm going to jump over to a quick screen share. So hopefully everybody can see that. Good. All right. So I'm at Texas A&M University right now. I'm the director of the Sketch Recognition Lab. I've been there since 2006. I have a bunch of research areas. I do sketch recognition, activity recognition, haptics, wearable computing, machine learning. For those of you who don't know, sketch recognition is the automated recognition of hand-drawn diagrams. And to give you an idea, here's a very quick video that shows basically a hand-drawn diagram being understood by the computer. You see the corners being found, an X translated into an anchor, a downward arrow representing gravity, another, more corners being found recognized as a body. Then we have a circle also recognized as a body, and then a pin joint, which is a circle representing connecting the two bodies together. And then most importantly, because it's understood, it can come alive. So that gives you an idea of what sketch recognition is. We've done this in many different domains, used it to automatically correct homework solutions that were hand-drawn, including in statics, Japanese language learning, biology, even coding. We've also done it to teach people to draw, so how to draw human faces, and that uses facial recognition software as well as sketch recognition software combined. And then we've sort of taken the 2D into the 3D, and we do a lot of activity recognition, recognizing exactly what types of activities you're doing, from sit-ups, jumping jacks, squats, lunges, etc., and being able to not only count them like a normal pedometer type thing, but actually tell you exactly which exercises you're doing, which is nice. And then we've taken that into some other domains, trying to help people quit smoking, by being able to predict when they're about to take a cigarette and when they are smoking, so we can do something to change those actions. And then as far as the wearable computing, we build a lot of interventions, so one of which is a haptic vest that is used both for soldiers as well as motorcyclists to give them awareness about their surroundings and navigational advice, and that was recently featured on the Discovery Channel. So at Texas A&M, I run a pretty large lab. So these are the people we've had over the past 7 years working for the lab. or a couple of them are faculty that directly collaborate with the lab. And so I have a unique experience at Texas A&M, and I'll stop sharing. So that, can you guys see me again? Yeah. So you're welcome to ask me about the questions about running a very large lab at Texas A&M, which is, it's a great experience. You get to influence a lot of people's lives. I really love working with the students every day. I work, at any particular time. We have a 30-person lab meeting at the beginning of every week where everybody talks about their research projects and we get to drive them forward. So those of you who are thinking about going into being a faculty member at a large university, large research university, I'm happy to answer any of those questions. So that's a brief introduction for me.
That's great, Tracy. Can I ask you a quick follow-up question right now, and then we can get back to things? So can you talk a little bit about what kind of research you did here at MIT? I assume you were in Core 6 or EECS.
I worked with Randy Davis in the doing, again, sketch recognition. We were Design Rationale Group was the name of the lab there. So we did some of that drawing recognition as well, and so I've basically taken that and expanded it from working, with a couple domains to working with many, but more important, developing a lot of recognition algorithms that can work with lots of different systems, as well as then taking it from 2D to 3D, and then to having that full system that basically talks back to you. So once you have this recognition, what are you going to do with that from the other side? So I would say that MIT prepared me really well for my faculty life here.
That's fantastic. Okay, that's a great kickoff for our conversation. I'm going to move on and give Alan Downey an opportunity to speak about what he's up to. So, Alan, can you talk to us about your work at Olin?
Sure, thank you. Yes, I've been here at Olin College. We're in Needham, Massachusetts, just outside of Boston, for 13 years. So it's one of the newest colleges around. The mission of the college is to fix engineering education. So it's attracted a lot of people who are really interested in curriculum design and engineering education. It's just a fun place to work, and that's one of my major projects is helping to build the curriculum here and constantly revise it. It's an experimental place. We're always trying new things, so it's a lot of fun for me to get out of computer science, where I did my PhD, and have a chance to teach engineering design and modeling and simulation, and currently statistics and Bayesian statistics and a whole lot of things I don't really know that much about. So I'm learning a lot. A couple of projects that I'm working on. One of them is a book series that I call Think X for All X, where the first book is called Think Python. It's learning the Python programming language, and then all the books that follow on that are based on the idea that if you have basic programming skills, you can use that as leverage to learn everything else. Because, for example, statistics and complexity science, I'm currently working on digital signal processing. In all of those areas, if you can write short programs and implement the algorithms and run experiments, you can learn things very quickly and learn them top-down by experimenting with Fourier transform, for example, which is what I'm doing in DSP, and learn how to use it, learn what it does, before you necessarily know how it works or how to implement it. So that's the book series. Think Python, Think Stats, Think Bayes is about Bayesian statistics. And then the third project, I have a blog that's called Probably Overthinking It, where I try to take ideas from statistics, both Bayesian and not, and apply them to real-world problems, make this stuff more accessible, more applied, more interesting than statistics sometimes is. So I've got a couple of articles that came from there. Last year, I did a study of internet use and religious affiliation. People who use the internet more seem to be less likely to have a religious affiliation, so that was an interesting result that got some attention last year. And the project that I'm working on right now, I've got a couple of students who took my Bayesian class last semester. They did Bayesian survival analysis for the characters in Game of Thrones. and they've got predictions about which characters they think will or will not survive the next television series. So that article is going to come out in the next couple of weeks, just in time for the premiere of season 5 of Game of Thrones.
Is there a betting market for Game of Thrones survivors in Las Vegas?
No, I don't know. There has to be.
There must be. Alan, can you go back to something you said right at the beginning? You said that the mission of Olin is to fix engineering education. And so I was curious about 2 things. So how did you wind up at Olin, and why were you attracted to that mission, and what the heck is wrong with engineering education? Tell us why Olin's doing it better than MIT.
Sure. Now I should say that's not the actual wording of our mission. That's my paraphrase. But I think a lot of us were attracted to that idea because we all had things that we reflected on in our own education that we thought had not worked well or could be better. And I think everyone here is just passionate about something that we want to make better. Two common ideas across the curriculum here. One of them is just that the notion of what engineering is has been too narrow. I sometimes describe it like a cartoon where an engineer sits in a box and somebody slides a well-formulated problem under the door. The engineer crafts a beautiful solution and then slides it out another door with no idea where the problem came from or where that solution is going to go. I think it's important for engineers to have the ability, first of all, to go out in the world, understand the people that they're designing for, identify opportunities, and not just solve a well-formulated problem, but be able to take a very open-ended problem and figure out what's the right thing to do and how do I formulate it. And then if you are able to craft an engineering solution, it's not enough to slide it under the door and hope that something happens. You have to go out into the world and find the ways to make it real. And we take that approach in our curriculum. We emphasize design as the first part of that, and entrepreneurship as one of the ways of getting an idea out of the lab and into the world.
Okay, fantastic. Thank you so much. Great to meet you. We'll talk some more.
Thanks.
So thirdly, let's go to Ari Trachtenberg at Boston University. And Ari, so you're working on encryption, specifically a form of encryption called deniable encryption. And I wondered if you could tell us a little bit about what that means and how it connects back to your larger research and maybe your training at MIT.
Sure. Do you want me to first go through my little intro?
Yeah, please do.
Okay. I'll get to the deniable encryption at the end, I promise.
Okay.
Let me just figure out how to share the screen. Here we go. Okay, so I got my bachelor's degree at MIT, course 18C, and my claim to fame as an undergrad was that I made it to the Tetris high score list. I was in 73rd place, which probably meant I played a little too much Tetris. But I then went on to University of Illinois, Urbana-Champaign. I did my master's there in what I would call course 6.2.5 in error correcting codes, and a PhD also in error correcting codes. But what's probably more important than either of those was my extracurricular activities, some of which had to do with encryption. Some of them had to do with data reconciliation, and a few other things on the side, like a dating server, and I can talk about that later. Here at Boston University, my aim is to, as it says up there, do the impossible, or at least the implausible, and until then I work on the improbable, which is really the publishable, and really that's just the fundable. So I work on what's fundable. So what is fundable? Well, we've done work on smartphone security issues. Here on the right you see some students doing measurements of the smartphone accelerometer on part of a project to see if the phone can identify its owner based on how they walk on their gait. On the upper left you see partial elements, parts of a fingerprint that the camera can lift off of people in the room, and on the bottom left is work on how to identify the keystrokes that a person types on a keyboard based on the audio signature that it produces for the phone. Other work that we've done is how to secure smartphones against remote exploits on the left, and how to attack the memory of a smartphone, and how the different models of storing memory actually affect encryption in practice. Okay, so now back to the original question. Yes, on deniable encryption. So deniable encryption is the idea of being able to encrypt a text with a particular encryption, so that if you want to, you can decrypt it to the original decryption, and if you don't want to, you can decrypt it to some other decryption. So let's say some bad guy corners you somewhere and says, "What do you have in this particular ciphertext?" You can actually show him something else that's not real and make it seem reasonable. So now, what was the original question, if you can remind me, Wade?
No, basically, I was just curious to have you defined deniable encryption, and then perhaps talk about how that grew out of your research at MIT. So kind of draw the line for us from MIT to what you're doing now.
Oh, well, I would say that the closest connection to MIT was cultural. The idea of, the whole hacking ethos at MIT, which I think is really kind of an ethos for research as a whole, which is trying to look at things that everyone uses in one way and see if you can do something completely different with it. And so that was the idea with deniable encryption. Effectively, it was based on other work that I had done as a graduate student on data reconciliation. And one day, the thought was, well, what else can we do with this particular hammer? And came up with a particular solution to this problem.
I have one sort of thing I'm curious about with regard to deniable encryption. The fake ciphertext would need to be pretty convincing, wouldn't it, to completely misdirect someone? I mean, you'd have to almost put as much effort into composing a plausible fake message as you would into composing the actual message.
Well, so one of the nice things is how easy it is to change a real message into a fake message that looks reasonable. For example, if you change numbers or if you change a word, there's this famous apocryphal story of a woman who saved her husband's life by commuting a comma in an execution warrant, which says something to the effect of the original phrase, and I don't remember the exact details, was something like execute him, do not save him, and she commuted the comma to after the not, so it said save him not, or execute him not, comma, save him. Of that nature. So, commuting small bits of text can actually significantly affect meaning. In this case, you can actually craft the message sometimes after the fact based on whatever it is that you want it to look like, up to a certain point. It has to be similar enough to the original text.
Okay, terrific. So that's a great introduction to each of the three of you, and what I'm going to do now is turn to some of the questions that are coming in from our viewers today. And I think I'm going to start with a question that each of you should be able to relate to. So the question comes in from Patrick in Stamford, Connecticut. And he's asking, do you think coding should be a GIR at MIT? GIR, of course, being a general institute requirement. Should all undergraduates at MIT have to take some computer science specifically? Should they come out, knowing Python or some other particular language? And probably here we can get into a religious debate about which language would be the best, right? But should coding be a required element of the curriculum here, or at your institutions for that matter? And so, Alan, do you have an opinion on that? How many people at Olin are taking programming courses? Is it close to 100%?
It is close to 100%. We don't have an introductory programming class that's a requirement for everyone. And I think it's a great question because it's one that we've wrestled with here. It seems obvious that anyone doing an engineering degree is almost certainly going to need to program at some point in their lives. And even if they don't need to, it's a superpower. If you can do it, just a little bit of programming makes a huge difference on so many projects. So if someone asks me if they should take the class, my answer is absolutely yes. But the other question is whether it should be a requirement. And the problem is it completely changes the atmosphere of a class as soon as you make it a requirement. So right now we have a great introductory class. It does use Python, since you mentioned it. And it's our job to make that class as appealing and as useful as possible, so that instead of saying you must take this class, we're saying, look, we're offering you the opportunity to develop this skill. If you think it's going to be useful to you, absolutely come and take this class. I think it's at this point about 80% of our students are choosing to take that at some point during their 4 years. And the great thing is that when I'm teaching that class, I've got a room full of people who are there because there's something that they want to learn that matters to them. And that atmosphere makes such a big difference for the outcome of that class.
So may I chime in here, or?
Sure, jump in, Ari.
So I think that it does need to be a requirement, but I don't think it should be a curricular requirement. What I mean by that is I feel that every engineer, and frankly, probably everyone with a bachelor's degree, needs to know how to code. We don't really actually teach coding. It's something that, we teach some of the meta elements of coding, but coding itself can be learned by oneself, as MIT does, at least in Course 6, right? Course 6 doesn't have any actual coding classes. So I feel that everyone should finish. It's kind of like the swim test. We don't force anyone to take a class in swimming, but they need to know how to swim, because otherwise they might drown somewhere.
So does that mean you're basically assuming that folks will absorb this skill somehow through osmosis, just being at a technical place like MIT? How do you ensure that happens if it's not a requirement?
Very easy. You make assignments that require coding.
Okay.
So just to add the Texas A&M perspective, can you guys hear me?
Yes.
Okay. So Texas A&M perspective, we do have some required coding for all engineers. We have a class called Engineering 111, 112, where they do learn some coding. The language for that has been changing from time to time. Tends to be C++. We do have Bjarne Strustrup here in our department, so the inventor of C++. So that has us sort of a little push for doing things in C++. But beyond that, we're actually thinking about restructuring and having a more formal class that is, because right now it's just part of the 111, 112 series, the coding part. But the big decision is, again, what language. So almost every department in the engineering school already has a requirement for them to take a programming class, and in fact, a lot of the ones in the geosciences college also have that requirement to have some sort of a coding class. But the main thing is that some people do want C, some people want Python, some people want MATLAB. So all these different languages cause conflicts, and a lot of them don't necessarily want 2 semesters of programming; they just want 1 in their desired language. So that's sort of what we're grappling with on how to solve that issue if we are going to do some massive, single course one. So I think it's going to end up staying to be, each department gets to pick their favorite language as what it is as per required.
Tracy, you're sitting in front of a few sketches that are on your wall behind you there. And,
yeah.
So I mean, your lab has got to be a place where there's an interesting overlap going on between coders and engineers and people who maybe think more visually. So I'm wondering if there's room in a lab like yours for someone who is more of an artist or a humanist and may not know a single line of C++.
Absolutely, but it's still super valuable for them to learn this other skill of learning how to code. So we hire tons of people from other departments who will add to the projects and contribute significantly. We have people from the communication department. We've had people from kinesthesiology. We've had people from dance, working on some sort of activity recognition with dance. So lots of other departments, certainly the Viz Lab. But when you're in computer science, if you're going to graduate from computer science, it is really helpful to know how to program, and not having that skill puts you at a significant disadvantage. So all of the students who I do advise within the computer science department, they need to be good programmers just for me to be a good advisor to make sure that they can survive once they graduate. But yes, absolutely, we love these other skills, and we have so, PhD student who's an amazing sewer. She's great for our wearable projects, all these different, although she's got an entirely different project, these random different skills certainly pervade throughout the lab, which is exciting.
Great. I want to pivot to another question coming in. It's actually, I'm going to sort of take off a little bit on one of the questions we got. This is from Sarah in Brunswick, Maine. And she has a question for Tracy. Will sketch recognition help online learning platforms like edX and MITx? And then I'd like to branch off that question and ask what Alan and Ari are doing, if anything, in the area of online education.
We have been talking a lot with the various edX people and all the different versions of that, because we do have some software that's close to being ready to put in a MOOCs type platform. Recent stuff has shown that with the exact same number of problems, they're learning at least as well and often better with the immediate feedback from the hand drawing solutions, which is great that it's at least as good as a person right there with you. So that shows a lot of promise of having it, putting it in a MOOC, allowing people to do something more than, I don't know if you've taken any of these MOOCs, but most of them you have multiple choice questions that you're answered, and that's sort of the limit of those, or else everything has to be peer graded, which brings in other issues. So this is really, we're very, very excited about this, and we're personally building basically a plug-and-play platform to work with a variety of these MOOC systems to add sketch recognition.
Great. So that's a way of making the offline part of the course, maybe the homework assignments that go around the MOOC.
More creative and more open-ended, and as opposed to these really discrete, is it X, Y, or Z, which is, it's a lot better for a student to create an answer than it is for them to identify the answer. It's a lot more difficult, and it shows better understanding, and they're having to use their brain a lot more.
That's a fantastic point. So Ari, what's going on at BU in the area of MOOCs? And I think we're sort of past the era of MOOCs 1.0, and everyone's trying to figure out what the next generation of MOOCs would look like and how to make them more engaging, I guess, since drop-off in involvement is one of the huge problems with MOOCs right now. Just keeping someone engaged all the way through the end of a course seems to be like the first problem to solve, and we haven't solved it yet. So, are you involved in any stuff like that at BU?
So, online material I've been involved with since coming here. I do a lot of things online. I have online competitions, stock market arbitrage competitions, AI competitions online where they have leaderboards and what have you, but they're mostly been focused on our students specifically. BU has started looking at the broader community, and we have a few courses that have been taught online to the larger community. I haven't taught it yet. I'll tell you, I'm a little apprehensive about the online model because I tend to be a very intuitive teacher. I really need to get the feedback from students' faces about what they understand, what they don't understand, what they like, what they don't like. And it's very hard, even a platform like this, where I can't see everyone else laughing at me while I'm talking, makes it very hard for me to craft my message. So I found it a somewhat unnatural platform to teach for me.
Tracy, you just chatted at me saying you have another comment. You wanted to jump in about MOOCs and student drop-off. So before we go to Ellen, why don't you do that?
Yeah, so I just had one other comment, which was that as far as the sketch recognition stuff, being able to see them, having it automatically correct their homeworks in real time, we have seen an interesting thing, which is that the people who seem to benefit the most from this are students that are taking the course in the off semester. So the students that are a little bit behind, needing to catch up, those students that it's more difficult for them. Why we're really excited about that and MOOCs is that so far it's been shown that essentially the people who succeed in MOOCs are people who don't really need help anyway. tends to be the lifelong learners. A lot of them already have a PhD or some other graduate degree, and so we're excited to see if this, if this idea that these different forms of correcting homework problems and engaging students, and will this extend over into the large MOOCs? Will it pull in those students who are otherwise sort of dropping out? So that's one exciting thing we have.
That's great to hear. Thanks. Ellen, so you're trying to reinvent engineering education at the same time that this online education revolution is happening all around you. So what are people talking about and thinking about at Olin in this area?
Right. I mean, we try everything. We've got a lot of experiments going, but I have to admit we're not producing a lot of MOOCs and we're not using a lot of MOOCs in the curriculum, in part because a lot of the curriculum that we've created is high contact kind of teaching. I spend a lot of time in the role of a coach working with students who are working on very open-ended projects. So a lot of the evaluation that I do is in a meeting where they are behaving like grad students. They're telling me what they've done since the last time we talked, what they're planning to do going forward, and I'm making recommendations about what I think good next steps are. And so that I think is the end of the instruction spectrum that does not lend itself to MOOCs. At the same time, I think the MOOC framework is really appealing. As Tracy was saying, the students get very rapid feedback on their understanding, and that's crucial to their learning. So I do think that's a part of it that I still find very appealing and would love to get into more.
Great. Okay. I'm going to pivot to another question. Sorry, Ari, did you want to jump in?
I just wanted to jump in on something Alan said, and that is, in my experience, sometimes immediate feedback is bad. Oftentimes when I get an email from a student, for example, I'll sit there and think about it for a while and give them some time, and sure enough, after an hour I get another email saying, oh, I just figured it out. That kind of learning is no less important sometimes, I think, than the immediate feedback learning.
Right, so how could you build that into a MOOC, or maybe that's beside the point? Maybe we're talking about two different ways of learning.
Yeah, I don't know.
Yeah, okay, thanks. So we have a question coming in from Christine in Cambridge, and the question is, are Course 6 entrepreneurs, and let's broaden this out to Course 6 alumni as well for purposes of argument, more likely to be entrepreneurs than other MIT graduates? So if you came out of Course 6, are you more likely to found a company? Are you more likely to work for a software company? What's your experience so far, the three of you? Ari, how about you go first?
Well, I'm laughing because we're the wrong people to talk to about that.
Well, so you're all in academia, right?
We're all in academia.
I would say that the Course 6 people that I've seen are more likely to do what they really want to be doing, whether it's creating a company or being a professor or whatnot. A lot of them are in their dream jobs. So.
Well, how do you think that happens? Do you think Course 6 encourages you to think more, methodically about how to get things done, or what you want your life to?
It's both methodically as well as the creativity, all the stuff, the hacker stuff that Ari was talking about. All of these things together encourage you to sort of push the boundaries and take those risks that you need to take.
I think that's a great spirit to work by. What's your experience, Alan?
Well, I'm going to give you the statistician's answer, which is that was a statistical question, so I'd want to see the data.
Absolutely. Okay. We'll leave that one open-ended then. Here's an interesting one that comes in from Jay in Seattle. All three of you trusted your video and your images to Google today here on the Google Hangout. Do you trust the rest of your data to Google?
No.
Ari, you don't?
I don't trust. In fact, I created a separate account just for this particular presentation today. And no, not because I think Google is evil or any of them are evil. I think that there is, Google has very good intentions. I think that there's a potential use or misuse by third parties unintentionally. We really have a very bad sense of the privacy implications of much of the technology that we have out there.
And yet people are buying iPhones and Android phones by the millions and deciding to entrust basically their whole personal lives to either Apple or Google or Facebook or Microsoft or a handful of other companies, all of which had been shown to have sort of backdoor connections or had been the targets of various kinds of NSA operations, right? So people don't seem to care.
Well, it's well known that people have a very bad sense of risk and probability, right? And marketers use that to their advantage to get us to buy stuff and do things. I mean, we just really have a bad understanding, right? We think terrorism is really dangerous, whereas really what's driving kills more people every year in this country than 9/11 does 10 times over. We have a very bad sense of risk of what we're doing, what's dangerous, what's not dangerous, and we'll learn the hard way.
Well, Ari, so as an engineer, do you have a sense that technological fixes can help us here, or I mean, if you have deniable encryption on your phone, is that going to protect you, or do you really need? Are we talking about behavioral and attitudinal changes here?
I think the solution is the same solution as we do with our locks. For example, locks, as anyone who went to MIT knows, are easily pickable. We all have very easily pickable locks on our doors in our houses. But yet, people don't pick our locks because there are police around and what have you. So the we haven't put bank locks on our doors because that's not the right direction. I think same thing here. We can throw technology at the problem, but that's ultimately the solution.
Okay. Well, so speaking of Apple and this whole world of ubiquitous mobile devices, we have a question from Julie in Ayer, Massachusetts, who asks, will you buy an Apple Watch? So I think I'm going to get one, speaking for myself, because I'm sort of an incurable gadget geek, but I am certainly cognizant that if I do that, I'm going to be drawn even further into the sort of vortex of Apple and its information about everyone, with an Apple device. So, but I think for me, it's just so cool that I want it. That's the bottom line. Tracy?
We're definitely getting an Apple Watch, several of them. We already code a lot on Pebble devices, which is, a similar type device. Apple has even more features on it, which we're excited about. We're excited about coding on the device. So, and doing what we can, of course, there are these huge privacy issues, but the advantages are so great as well. So it's hard to fight that.
Yeah, so Tracy, I mean, one of the cool things that that Apple's been showing off is this way you can use the watch to kind of send a little sketch to a friend of yours in real time across watches. Is there a role that, on an interface that small for sketch recognition?
I was just going to say that it's such a small space that it's a little bit ridiculous. But you can do things like with activity recognition. So sketching in a large, with your wrist or your hand. It should be able to get a nice sketch that way.
Oh, you mean just by waving your hand around?
Talking about? Yeah.
Using the accelerometer.
Yes, exactly.
Exactly. Okay.
And so you could even sketch on a piece of paper with your finger with a pen, and then it would be able to track that location.
Alan, what about you? Are you going to get an Apple Watch?
Only if it runs Linux.
Well, wait a minute. It probably does at some level, right? Okay, Alan, we have a question for you from Srishti in Cambridge, and I'm just going to read this. It's a long question, but you mentioned that at Olin you emphasized students going out into the community to find users to design for. During this design phase, how do you help students to scope down their ideas? How do you ensure you're giving them enough freedom and agency for their own ideas, but also making sure they will get something out of what they're designing? So it's an interesting balance. So how do you handle that?
Right. Well, that's a big part of the design of these classes. There are several like that where we've got external engagements. Early in the curriculum, they tend to be more heavily scaffolded. So they're getting explicit instruction on ethnography, explicit tools for collecting that data, bringing it back, representing it, communicating about it. Later in the curriculum, we gradually take away the scaffolding. By the time they're working on a capstone project in their senior year, they're really behaving like an engineering team. They are almost completely autonomous. When I'm advising one of those teams, I behave like a manager. I meet with them about once a week, removing roadblocks, giving advice, but by that point in the curriculum, they're really acting on their own.
Okay, great, John. So yeah.
I also teach senior capstone design. That's one of the main classes that I teach every semester. And that's, a really interesting problem trying to, because I feel like one of my jobs in that is to fill in all of the gaps of anything that they might have been missing throughout their entire 4 years, which can be intense. Sometimes they do run pretty autonomously, but a lot of times there are things that you find that they miss somehow during their 4 years, and it's always different in each team. But the managing things is always a big issue. Trying to make sure that the students understand that the product has to work at the end of the semester, and if their product, if one of the team members sort of drops out of the project, the rest of the team members have to pick up that slack, which is a huge issue. Keeping that creativity throughout the semester is a big deal, and we do a lot to ensure that keeps going on.
Okay, super. So, Alan, this is a lightning quiz question for you. Actually, just see if you can squeeze your answer down into about a couple minutes, since that's how much time we have left. But John in Menlo Park says he's read 2 of your books, Think Python and Think Complexity, and says he found them to be really rich and useful. Can you describe why you wrote those books and why you took the pedagogical approach that you used? And maybe in the process of answering, you can say what that pedagogical approach is.
Well, I mentioned part of it is the idea of using programming as leverage to learn everything else. What that allows me to do very often when I'm writing, I explore by writing code and implementing it, and then a big part of the chapter that I write will be explaining that implementation in order to lead the reader to be able to do similar kinds of things, to extend what I've done or solve a different related problem. It's an efficient process which lets me write books that are small that students will actually read. If it's an 800-page, 1,000-page book, they're just not going to read it. If I can get it down to 10 or 15 pages a week, they really can read and understand that, and then we can use the class time to build on that.
Okay, well, fantastic. So we are just about out of time. So I would like to thank today's panelists, Alan Downey from Olin College, Ari Trachtenberg from Boston University, and Tracy Hammond from Texas A&M. I would like to also say how much fun I had today being the moderator, and this is a real privilege to be helping the Alumni Association with these new kind of experimental types of communication. And on behalf of the Alumni Association and my own program, the Knight Science Journalism Program, I'd like to thank everybody for tuning in today. We actually got through most of the questions submitted, but not all of them. And if you'd like to submit more questions, we'll be certain to pass them on to our panelists afterward. And I was asked to say that if you want to tweet about this event, you can do that using the hashtag #MITAlum. And you can also send feedback and questions to alumnilearn@mit.edu. So that's it for today. Thanks everyone for participating, and thanks for tuning in.
Thank you.
Thank you.
Take care. Bye-bye.
Bye.